units, or FU. And so you could tell your computer to FU. I frequently felt that way. And another part of it was the extended mutable type system. So we'll talk about that a little bit more. One thing to know is that the prototype was actually used a different model of composition compared to what we eventually shipped in PowerShell. So this is what his prototype looked like. The noun and verb were reversed, everything with slashes, but you'll notice that sort and select, which are commandlets in PowerShell, look like options. And so it was an extension model based on adding options to existing commands. It had a limitation though, because order matters, right? If you select first and sort second, you get a different result than sorting first and selecting second, depending on what you're doing. The final PowerShell syntax ended up looking like this, where there was a clearly visible distinction between the functional units. So Monad begins. Jeffrey publishes the Monad Manifesto. If you have not read it, I recommend reading it. I recommend reading it every couple of years just to keep it in mind, because it's a remarkably prescient document. And so some of the goals for PowerShell, some of the things that we're trying to accomplish. One of the goals is that easy to use is very important. And that means it may be more important than simple. We should be able to accomplish a sophisticated task with a minimum of effort, but it might be, you might need to know a lot of stuff to be able to do that. An example of, a strange example of simple is the ability to actually paste from Word documents into the command line. That actually required a bunch of work in the parser to be able to handle the M dashes and N dashes, but it made it very simple to take stuff that somebody had written in a Word document and just use it, and made sharing easier. So learning is hard, and so we wanted to facilitate it and protect the user's investment. This is the sacred vow that Jeffrey has talked about frequently. To facilitate learning, we wanted to be consistent. Once you learn a rule, you should be able to use that rule over and over. You shouldn't have to unlearn or learn a different rule. But at the same time, we were trying to avoid the foolish consistency where you make everything look, things that aren't similar look similar. And that can be confusing to the end user. One of the big goals to address was the tension between whippetupitude, which is a Perl word, for being able to easily construct a complex piece of script with almost no effort, versus writing production code that people will be able to maintain 10 years down the line. So PowerShell has a very wide dynamic range. You can have a user who doesn't understand scripting at all, simply typing commands into PowerShell, essentially treating it as a user interface. Or you can write, well, if you saw some of Jared's stuff yesterday dealing with Win32 type system, you can do some pretty sophisticated stuff. And as part of this, it's not just one thing. So it's not just commandlets. It's methods and commandlets. It's simple functions and advanced functions. It's aliases and short options to give you this sort of elastic syntax. And it's up to the user to understand their scenario and use the right, I hesitate to say mode, but the right level of exposition. So in the upper line, you can see get process. So a typical PowerShell, fully elaborated command line, it's actually fairly long. But if you need to whip something up quickly, just on the command line, then the lower line shows you the same command but compressed significantly. So this is what we mean by elastic syntax. It can expand and compress. Some guiding design principles, leverage as much as possible. So we're trying to practice extreme reuse. Nobody should have to write the same piece of code over again. So common argument processing for all commands, ubiquitous parameters in all commands. We have command runtime services for handling wildcards, so nobody should write their own stuff for doing that. We have path handling libraries. So a whole set of services that give you the PowerShell semantics and let you avoid writing code. Common formatting and outputting. So if you look at a lot of sort of Unix commands, you'll find that 30% of the command is argument parsing, and 50% of the command is formatting and output, and only about 20% is business logic. So by extracting all that formatting and output into a separate subsystem, it reduces the size of commandlets. Commandlets should never really be doing any formatting. They should take advantage of the formatting subsystem. People time is more important than processor time or disk space. And an example of this is the get content commandlet. If you do get content on a text file, you don't get back an array of strings, you get back an array of PsObjects that have the line number that the line came from, it has what file it came from, et cetera, et cetera. So, I mean, there's typically more metadata than there is data on these strings. Just in case the user might need to know this stuff. So we expend resources in advance to possibly simplify the user's experience later. That was the idea then, because then CPU was cheap, disks were cheap. In this world of cloud and many virtual machines on a single piece of hardware and IoT, resource constraints are back. Resource constraints are hot, and so we need to maybe rethink some of these decisions. One of the things we wanted to do was to provide friction on negative paths. This doesn't mean we're going to keep you from doing things. We're just going to try and keep you from doing things that are bad. So requiring -force, for example, to overwrite a read-only file, using the confirm parameter for destructive operations. There's a variety of other little things scattered throughout the runtime that try and discourage you doing bad things. You can still do it. You know, we're just not like, you can still shoot yourself in the foot, we're just not going to hold the gun, for a really inappropriate metaphor. We also wanted to facilitate experimentation. You should be able to try things out and not destroy your system, and so we have the what if ubiquitous parameter. So the project begins, we get a team. Awesome. It's staffed out of India Development Center in Hyderabad, India. All of the architecture owners, all of like Jeffrey and myself and so forth, we're all still in Redmond. And the development and test was going to be done in India. But radical experimentation does not flourish with 12.5 hours of time difference. It just took too long. If you get an idea and say, that's really cool, and send it to the guys in India, and they say, oh, we think you could do it this way, and then they send it back to us, that's a whole day. It's just too long to do rapid development. And so first development and then tests were pulled back to Redmond just because it wasn't practical. Interestingly, it might be practical now with things like GitHub and so forth to do this kind of globally distributed development. But at the time, with email and so on, it wasn't really possible. So we weren't using the team in India anymore, so we had to go out and get a new team. And so we found the Windows Management Pack team. They had done a lot of tools for managing Windows. They had a lot of Windows management experience, and it seemed like a good fit. So we now have a team, we can start in earnest. Oh, and by the way, we changed buildings again and again and again. Six times total in 2 years. It was, yeah, which building am I in? I don't remember. Oh yeah, one more thing. We had to be ready to ship in 2 weeks. Because this was the Longhorn time frame, and Longhorn was the first attempt at what became, the first attempt of which the second attempt became Vista. And my impression of it at the time is that Microsoft was dipping the toes into continuous delivery without having any of the infrastructure or understanding of what continuous delivery involved. So this made it exciting. You had to rebuild your dev box at least once a week. This also meant that the initial release plan for PowerShell had not much more than Jeffrey's prototype plus Control-C handling. So no performance, no coverage. I think there were 6 commandlets. No ability to write scripts or functions, which is kind of useless for a scripting language. So really there would have only been an interactive experience. The chances of success were not high. This was totally not ideal. Good thing it didn't happen. So we had a bunch of big ideas. So what I talked about a minute ago was sort of abstract guiding principles. Now we're going to talk about some of the more concrete design decisions that went into the architecture of PowerShell. Noun verb naming. So this idea of domain-specific vocabularies, as contrasted to domain-specific languages. Domain-specific languages have, a domain-specific vocabulary has nouns and verbs. A domain-specific language has articles and participles and all the other all of the things of language that are not nouns and verbs, which means that you can create you can create a language so different with a DSL that it's not really readable to the person who's familiar with the base language. Jeffrey's idea is that we would do domain-specific vocabularies with strong guidance. So noun-verb naming conventions, we wanted to encourage the use of a constrained set of verbs. We provided guidelines. This made the user's experience predictable around the actions that they could take. And it was a very small set of verbs, and surprisingly, it's only grown by a handful in 16 years. So I think that was actually a remarkable success. These verbs were organized into groups or families, so life cycle, security, diagnostic. They're somewhat akin to the idea of an interface, but they're not enforced in code. We did explore the idea of having what Kenneth called commandlet families in version 3, but we never got as far as implementing it. It's up for grabs. Verb pairings, again, inconsistency. If you have a start verb, you shouldn't have an end verb, you should have a stop verb. And then because we had these very verbose command names, we wanted to have aliases to make it, to address the whip it upitude part. And we actually have two types of aliases, which I don't know if you know that. We have the canonical aliases, which are derived from the name of the command. And we have the convenience aliases. And the convenience aliases, now that we are open source, have turned out to be inconvenient. More on that later. Another big idea was this common parsing. Commands are not responsible for parsing their own parameters. They get a fully parsed set of parameters. The parser itself, the language processor, does all of the parsing. It does the same parsing regardless of whether it's a commandlet or a function or a native command. That is 100% common to all command types. And then the mapping the parsed parameters to the specific command is done through, I guess you would call it a strategy pattern, where a command type specific parameter binder is used to take the raw parameter data and bind it to a specific command instance. And if you look in the source code under automation engine, or system.management.automation engine, you'll find a whole bunch of files called parameterbinder.cs, and these have the binding logic for each of the command types. This gives us broad consistency across all the commands, except for native commands, because they do their own argument parsing anyway. The interface on Windows to a native command is a simple string, and it's up to that command to take. So we parse all the arguments, we turn them back into a string, we pass the string to the native command, which then parses all of those things back into arguments. And the Windows commands are idiosyncratic as far as how they do the parsing. So what we try and do is we take the original commands on the command line in the script, and we try and synthesize what we think the native command is going to want. And there's a bunch of hacks that do this. Apparently there need to be some more hacks because it's insufficient. But the net result is it works for a lot of stuff. Unfortunately, it doesn't always work, and it's frustrating to make it work around it. Declarative parameter constraints, so as well as parsing all the parameters, there's parsing parameters and there's parameter validation. Rather than writing a whole bunch of imperative validation logic, we wanted things to be as declarative as possible, and so you can use these attributes that say this parameter should be not just an integer, but it must be an integer between 10 and 12. Or it can be a string, but it has to be one of these 3 or 4 strings. This metadata both does two things. One, it means that you can do parameter validation. Okay, that's 3 things. It means that you can do parameter validation without writing any code. It means that when the user gets an error message, they get a consistent error message every time. And then finally, the metadata is available for tools like IntelliSense to be able to tell you that, oh, this parameter takes a string that's one of this set. I can show you that set of strings in a dropdown. So it helps you drive IntelliSense. So simplified code, common error message experience. Sometimes the experience can be suboptimal. For example, validate pattern, which takes a regular expression, should be awesome, except that the error message that it generates by nature is you didn't match this regular expression. And since regular expressions can be very confusing, it doesn't produce a very good error message. And sometimes this whole idea of parameter validation just doesn't work, as this comment that I've extracted from one of the process.cs that defines the process commandlets. The process name glob attribute was deeply wrong. I have removed it. Providers was another big idea. We were sitting around in a conference room going, geez, we're going to need an awful lot of get commands, get registry, get this, get that, get alias, get function, get variable. And then somebody, and I don't actually remember which of us it was, came up with this idea that, well, maybe we could just use common commands because the operations are essentially the same and vary on the paths. And so we came up with this idea of a pluggable provider model. So we developed what are called the core commandlets, the item, child item, and item property commandlets on top of providers. Providers are called providers, except in the source code where they're called namespaces, and sometimes in Jeffrey's talk they're called namespaces. But I digress. And one of the things that we sort of discovered is that you could access everything through providers. This eliminated a lot of stuff. So you could, file system, sure, that makes perfect sense. Registry is a hierarchical data store. Accessing it in a similar pattern to the file system makes sense. But things like internal data structures, a PowerShell, like functions and variables, can also be accessed. We don't need to create a remove variable command. You just do remove item in the variable drive. Likewise, the environment and things that are like the WSMan configuration is exposed as a hierarchical data store through a drive. And basically, one of the symmetrical aspects of it is that you could access variables through the core commandlets. You can also access the core commandlets through variables. So, for example, this expression copies the contents of XXX to YYY through simple assignment. Streaming. Streaming is good. We definitely wanted to have a feature, this to be a feature in PowerShell, but the way Unix did it wasn't going to work for us. It did create process, spawn multiple processes that all ran concurrently. Part of the problem is that creating executables on Windows is pretty heavyweight. So that would have made things very slow. But the other thing is, to get the object semantics, we needed to run everything in process, because otherwise we would be going through a serialization boundary that again would kill performance. So this traditional approach couldn't work. So the first thing we tried is doing multiple threads within the same process. This would have been better than creating new processes, but it would also still have been very, very heavy, and there were synchronization problems and so on. So we didn't do that. Instead, what we do is we sequence objects through the pipeline one at a time. So the first commandlet essentially pushes an object to the next commandlet, who pushes an object to the next commandlet all the way down. Pipeline is driven from the first commandlet until the end. But there was a problem with streaming as well. Not all is skittle and beer. If you're returning an array through streaming and you're returning one element, it's completely ambiguous as to whether that is one element, is a scalar, or an array of one element. The cardinality gets lost. If it's 2, then fine, it's an array. If it's 0, well, who cares? If it's 1, well, I don't know what it is. And so this causes problems. We try to mitigate it with the array sub-expression. It guarantees the output is always an array. But it's still, I'd still like to have a better solution for it. If anybody has a bright idea, please let me know. And then the operation of the pipeline, in PowerShell version 2, we actually made the pipeline processor. If you saw Dongo's talk, he talked a little bit about this class. It's an internal PowerShell class. We made it external in the form of a steppable pipeline, where you can create a pipeline with a series of commandlets and then send objects down one at a time. Now, it was introduced in V2. I'm talking about V1, so pretend I didn't say this. Another big idea, management, an extended type system. We wanted a management-oriented type system with a lot of consistency, a bunch of other characteristics layered on top of the .NET type system. We had this wonderful dream where not only would we have this management type system, but we'd have a central way of patching types. Oh, there's a bug in this method. We'll just patch that method by sending out an update to the type system. That did not happen. It's interesting. I think the performance characteristics would have been, well, think about using AD to patch a method. You kind of get the idea. One of the things that we did do is we worked with a large group of folks inside Microsoft who were producing .NET commandlets, who were producing .NET classes, and we talked with them about this idea of having this consistency, and people were really open to it. They really thought it was a good idea, but they were busy, and so were we. And so the only part of it that actually shows up is that arrays have a .count property in PowerShell, and they don't in .NET. So it was another idea that seemed fantastic at the time, but nothing ever happened. We have a synthetic type system, so this works with deserialization. We don't deserialize into the original type. We deserialize into a property bag that remembers the type that it formerly was. It's also allowed us to construct new objects, new instances, but not types, not in V1. PsObject, so continuing on with the type system. Jeffrey's prototype only handled extensions on classes, so you could add, I'm not even sure the terminology to describe it, a static instance method to a class. But we wanted to have the ability to attach data to individual objects. And so we have PsObject. This is an object that wraps other objects and contains the type information about the object that it contains. So instance-specific things like PsNoProperty and PsScript property. It simplifies a bunch of stuff. When you're dealing with PsObject, you always go through this one relatively small interface. But at the same time, it means that you have to go through this relatively small interface. And it also means that your code has to deal with a situation where it may get if you declare something that takes type object, you have to be prepared to deal with getting both object and the PsObject. In general, we recommend using PsObject as your argument type, simply because the parameter binder will take care of wrapping it in a PsObject, and you won't have to write all this extra logic. And so if you ever wonder why all of our object commandlets take PsObject, not object, this is why. It just simplified the commands and reduced errors. We spent months playing whack-a-mole with errors that were a result of people forgetting that they had to deal with a PsObject. So, and there does seem to be some, so PsObject is part of the API, but the API is part of PowerShell. Remember I said methods and commandlets. And so PsObject is largely invisible to the PowerShell user, but it's not completely invisible, and sometimes you actually need it, for example, to get at member sets. So it is part of the shell user's experience. It's not just an API. One big change in PowerShell v3 was to change it. So v1 and v2 had these wrappers. v3 changed it so that it had wrappers that had a problem of aliasing. You could take the number 1, of which there is only 1, and then wrap it in 2 different PsObjects, and so they would be referentially distinct, which is confusing. Jason in PowerShell v3 changed the type system to use weak references for the object type. So once you create a PsObject, that PsObject is always associated with that object instance, which means that you don't end up with this aliasing problem, which actually broke some people because they depended on that aliasing problem. We would in fact be able to go through and change all of the source code and probably extract PsObject and replace it with something that's called mirrors, but that would be a lot of work. That would basically rip PowerShell apart. Okay, so we did typeless objects with PsCustomObject. The PsCustomObject also confuses people because PsCustomObject is the typeless is the type of the typeless object. So you have a PsObject that contains a PsCustomObject. The PsObject contains all the data. The PsCustomObject simply indicates that it's a typeless object. And so when you do new object PsObject and new object PsCustomObject, you get a PsObject both times. Yeah, we could have done better on that. We made it really, really easy to do, starting I think in V3, to create custom objects out of hash tables. You could do it in V1 with add member. Add member is a bit clunky. It's much easier to do it in V3. And for those people that wonder why not just use the hash table, the distinction is that with PsObject or PsCustomObject, the set of properties are fixed. So in a hash table, you can say $hashtable.property that does not exist equals 2, and now the property that does not exist exists. If you try to do that on a PsCustomObject, you get a property not found exception. So it gives you a little bit more rigor than a hash table. Error handling, so universal streams, error warning, verbose debug, and then in, again, no, V4, I think we added the logging stream. And so all of the commands use these mechanisms to do all their error reporting. A commandlet should write an error, it should write a warning, and then the runtime will take care of the disposition of those objects. We have live logging in $error. And if you've ever written a program that uses $error to check the result of the execution of your program, please stop. $error is just a log. You'll have no idea what's in it. I mean, you can look at it and you see all the things that have happened, but there's no guarantee that the error that's the first error in the collection is the one that you're actually really interested in. So just treat it as the event log and you'll be happy. The other funny thing about error is there's actually an array list instead of an object array, which we use pretty much everywhere else. Array lists expand, and so it is more performant to be an array list than it is to be an object array, with the caveat that, well, it's a different type, and so people might not be familiar with it. It works largely the same as an array, except that you can add objects to it. I think the trade-off of performance versus the possibility of slightly confusing somebody is probably reasonable. Terminating and non-terminating errors. This seemed like such a good idea. Non-terminating errors are for shell-like semantics, so if you're deleting a directory of 10,000 files and 5 of them you can't delete, rather than having, like, you have 10,000 files, 5 you can't delete, and the third file in is one of the ones you can't delete. You start doing your remove item, and it stops. Because with non-shell semantics, it would stop, and then you'd have to fix that one, and you start it again, and it would stop. You have to fix that one, and you start it again, and then it would stop. So with the shell semantics, it'll go through and it'll do all the work that it can while reporting all the individual errors. And then you can take, the theory was to take those error messages, which would contain the name of the thing that was a problem, and you'd be able to pipe those error messages into a new command to fix the problems. So that's all very slick. Great interactive experience. It is perhaps somewhat awkward for programming. Yes?
But you just told me not to use $error.
Correct. Yes, so you have -error variable. -error variable will actually capture, or you can use redirection. It will capture the errors. Don't use $, So don't use $error. Because that's just a live list of all of everything that goes wrong in the runtime, things that are in your prompt, whatever. But if you have a commandlet, you can use -error variable to capture the errors that are specific to that commandlet, and then you can use those to manipulate. I don't know if people do that. I think they just go back and fix it manually. So anyway, terminating and non-terminating, they're not different kinds of errors. A lot of people say, well, what can I tell what type of the error it is? Well, the type of the error is an error. It's not a different type. It's a different disposition. That's why we have error action preference, right? You tell the runtime what to do with that error. Should it terminate the pipeline? Should it be a script terminating error? Or should it just go to the error message? So there's at least one issue open on being able to tell what these things are. And it's a question that's hard for me to understand because they're not different types. And the same thing, it can be thrown and caught and written and captured and thrown again. So what type is that? Right? It's every type, but at different times. So that's what it is. It's not simple, and it's clearly confusing. I'm not sure what we could do to make it better. Checking command execution status. The other thing about shells and that type of language is that they don't do exceptions, right? They return their status in an error code. So $? tells you whether your command had an error or not. And it's up to the command to tell you that it did. And so you do your command and then you just test $? I just said you can get all the error messages, but typically with streaming error messages, it's a little awkward. It's awkward to capture them and determine whether you have an error you care about. $? is supposed to be the thing that you check to see if your command had an error. And then last exit code gives you the actual status for native commands, because we made $? a Boolean, not an integer. Oh wait, we do have exceptions. How exceptional. Version 1 had a trap statement. It's one of these things that we took from Perl 6. It's very much like the VB on error statement. It transfers control to the trap, and then the trap can transfer control to either it can throw or it can continue. It is lexically scoped, right? Whereas most things in PowerShell are commands that are executed at runtime, trap executes, in quotes, at compile time and sets up a trap handler for the compile unit, that piece of text that you're executing. And anything else that it executes, right? Because it's a dynamic stack. But you can't register a trap handler, a durable trap handler in memory. So if you type on the command line trap, blah, 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 that will be the trap handler for the command line that you typed. And as soon as that command line is done, the trap's gone. We did think about having a way of creating durable traps. But it would have required either creating a trap provider, that would be really interesting, or having get trap, remove trap, add trap, delete trap, and that was just a whole lot of work that at the time didn't seem to be that important. Yes, it was completely a trap. Break and continue. How am I doing on time? Break and continue. You can break out of loops. You can continue in loops. You can break to a labeled loop. Something that's significant to be aware of is that the label passed to the break keyword can be an expression. So in this example, $L is not determined until runtime. This has a weird side effect. Uncaught breaks propagate until they are caught, because you don't know what the label is until runtime, so you can't do static checking to verify that there is actually a label corresponding to the label that you're throwing. So you just keep going. It's pretty weird. It has limited utility, but it's not useless. It's rather like C's set jump long jump construct. It's something that I've used, for example, in deeply recursive parsing functions, where I want to be able to unwind out of the recursion and try a different production. But that's me. So break and continue in traps, again, allows you to control what happens if you continue in a trap, then it resumes execution at the statement after the statement that caused the trap. Security, it's a good thing. You should have it. I recommend it. So secure by default. This was the mantra at Microsoft and on the team at the time. We did threat modeling, so threat asset mitigation. We had some really weird issues trying to figure out what our assets were, like we were trying to protect one variable from another variable, and heaven forfend, the commandlet might access a variable. So that made things complicated. Eventually we did figure it out and came up with a solution. The other thing we struggled with at the time was code access security. This was very, very hot in the CLR at that time frame. Code access security was a capabilities-based mechanism for allowing trusted code to be able to call untrusted code. So the trusted code would assert a set of capabilities. The untrusted code would demand a set of capabilities, and if the demand was equal to or less than the assert, then that code would run. It was a nightmare and is deprecated. And we just ripped all that stuff out of the PowerShell at runtime. So anyway, for the security model for PowerShell, the trust boundary is at the run space. Untrusted code must cross the run space boundary. We'll talk more about that in part 2. But we identify code coming from outside the run space as being from outside the run space. Oh yes, an execution policy, it's a safety belt, it's not a door lock, right? It's not a security boundary. You use it to mitigate risk by reducing the chance of accidents. And so when you choose your execution policy, it depends on what you're doing, right? We generally recommend remote signed as the minimum secure policy. At least that's what we recommended the last time I looked. It could have changed. Implementation, the initial design was really componentized. Most of the stuff lives in the engine subdirectory of SMA. Some of the pieces, we had run space configuration, we had the language stuff, we had execution context, which we'll talk about a bit more. We had command discovery, that piece of code that goes out and figures out where a command comes from, pipeline processor, the air handling subsystem. So we had a ton of these pieces, and you can think of them as Lego blocks. The downside, so it's very flexible. You could build a really small shell. You only use the pieces that you needed, and that could give you a much reduced footprint. But it also meant that you had to build this thing and pick the components, and that it made it very difficult to build a shell. So to simplify everything, we came up with this, or Jeffrey, very specifically, came up with this idea of a run space where all of the components are encapsulated inside an object. And you just create an instance of this object and you're ready to rock. A run space is a space where you run things. Why is this so hard? Like, people don't get it, but that, again, I have no idea. The side effect of that is that, and this is sort of interesting, is that we had run spaces when we were doing remoting. They said run spaces were hard, let's do sessions. So we have a session object that wraps the session wraps run space, that wraps automation engine, that wraps execution context, and is turtled all the way down. We followed .NET guidelines as they existed at the time. So we sealed all the classes that weren't visible, explicitly visible. This was intended to mitigate versioning. So when you add a new member to a class, you are in theory breaking the class signature in an unsealed class. It's a pain. Derivation is pretty useful. I think the .NET guidelines have changed to say, oh yeah, just unseal everything. We made everything internal unless it was an explicit API. We made a lot of things that are useful to the end user, like the language primitives class, which contains a lot of utility routines that have PowerShell language semantics available to the C# programmer. It should have been public, it was not. All of our APIs return collections. They never return null. They return an empty collection instead. This inspired me to make prevent you from ever passing a null string to a command. If you passed a null string to a command, it automatically got converted to an empty string, so you would never get a null pointer exception. And people hated it. I don't know. Sometimes you can be too clever for your own good. Favorite generic collections over polymorphic collections, so pretty much everywhere in the PowerShell source code you'll see collection or list or whatever. Generics were introduced in the CLR2. We started on CLR1, so we had to do this massive pass through the code and replace all of the array list instances with lists of things instead. We didn't do it everywhere. Like I said, $error is an array list. There's still a few array lists kicking around, but we did a pretty extensive pass through returning a collection of PsObject. All the APIs for interfacing with the engine return collection of PsObject. And we broke a bunch of rules. There was a rule that said, "Thou shalt not pass," or you shall not return arrays from a class or property. But we didn't want to return arrays, we wanted to pass in arrays. And there was no way to say, yeah, there was no such thing as a write-only property. So there's a lot of pragmas in the commandlets that cover this. We use a lot of object-oriented design patterns in the code. So again, if you're aware of this, it can make it easier to read the code. So basic concept of prefer composition over inheritance. So we use the adapter pattern for type system. We use facades for commands and command processors. We use the strategy pattern for parameter binders. And some of these are public extension points. The command processor extension point, you could add arbitrary commands to it, but you couldn't But it's private, it's hidden, right? So you could have a command type that does an HTTP request, pulls down the source code and just executes it. That could have been a built-in command type, but we don't let you do that because we made it internal. Factory pattern for runspace factory. We actually named it factory. Context objects. So I mentioned execution context earlier. So this wraps up all of the engine in a single object that you can pass around. It's an internal object. It gets passed around everywhere. So every command that executes gets the context object for the run space that it's in. This eventually got so complicated that we gave up on trying to pass it around and introduced this new new method where it retrieves the execution context from the currently executing thread, which has its own world of interesting things. Commandlet provider class, commandlet provider context class, this does sort of the same thing for providers. We have externalized a lot of those services through wrapper classes with some weird naming things. So session state, the public session state class is actually not the session state class. It's a facade around the session state internal class, which is the real session state. And then to be completely consistent in our naming, we expose $execution context is an object of type engine intrinsics, which wraps the execution context, which is private. So our naming is sometimes weird. But the important part about wrapping everything into context objects is it means that we can have multiple run spaces per app domain. Another thing to be aware of is that scriptblocks and objects are affinitized to the run space. And this is for the C# programmer. If you execute a command in the PowerShell engine and it returns a bunch of PsObjects, those PsObjects may contain PowerShell script code. That script code can't be executed outside of the context of its run space, and so it has a pointer to the run space. So that works okay if you're dealing with one run space. Sometimes it can be confusing where you take an object from one run space and pass it into another run space and then invoke a method. That method actually gets invoked in the first run space, and it may cause an exception because we're aggressively single-threaded. But you'll see this in the code again, this getting this execution context. PowerShell language. In the original architecture, the language was supposed to be a separate piece. You'd be able to unplug PowerShell and plug in VBScript, for example. That did not happen. In practice, over time, the language became much more deeply embedded into all layers of the engine. For example, the formatting and outputting system had script properties which required the runtime, which in turn required the engine, and so on around. So you can't really separate the language from the runtime now. Language roots. We started with the IEEE POSIX.2 shell and utilities, well, shell grammar, basically corn shell, bash, etc. From the shell, we got variables, sub-expressions, $? We got pipelines, dot sourcing, and direct execution of commands. And again, people can get confused about PowerShell, and they think that they need to use start process to launch an executable. But you don't need to do that. You can just run it. It just makes things much easier. Parameter syntax was in part inspired by DEC's DCL. So the colon and the argument. Jeffrey had a background well, he'd worked for DEC, and there's a lot of stuff that he liked about DCL, and a small part of which got added to PowerShell. For the concepts that weren't in the POSIX shell, and there were a lot, we initially started looking at Perl. Perl was the dominant internet scripting language at the time. It had hashes and arrays and regular expressions and all that cool stuff that everybody wants. And it had one thing that we really wanted, which was CPAN, the module archive. You could do almost anything in Perl by grabbing a handful of modules and stitching it together with a little bit of code. We did retain some syntactic elements from Perl, $underbar, the use of @ in places, the call operator, regular expressions, and so forth. But Perl was kind of icky. You could basically generate arbitrary line noise and send it to the Perl interpreter, and it was a valid script. Your cat could write valid scripts by stomping on the keyboard. We thought that would be non-optimal. So we switched our syntax model to align with C#, which of course means that we're aligning with all the other C-based languages like C++ and awk and Go, and incidentally, Perl. So there you go. So our value proposition became in part, if you knew PowerShell, then you could move on to C# and leverage your knowledge of the syntax. If you knew C#, you should get onto PowerShell pretty easily. This protects the student's investment in learning, but sometimes it's problematic because PowerShell falls into the uncanny valley a little bit. It's very close to C#, but it's not exactly C#. And that confuses people. There are lots of people who want to turn PowerShell into C#. There are lots of people who want to get rid of all the C#isms. Your mileage may vary. This is not your parental unit shell. Almost all shells are expand and parse, which means these shells read a script line by line. They do all the variable substitution, gives them a new string. Then they parse that string and execute the resulting string. So for example, if you have a command that looks like the first line, the user types $command, $foo, and so on. You go through and do a pass for variable substitution. So now you have concrete commands, command name, and you have the two argument strings. And then the interpreter parses it into 3 pieces. And the thing that you'll note in the parsed version is there's no unresolved text, right? All the variables are resolved at this point, and then that gets executed immediately. PowerShell fully parses the entire script. In PowerShell v1, it compiled directly to an expression tree, which was then evaluated. In PowerShell v3 and so on, it uses the intermediate representation of an abstract syntax tree. Dongbo talked about that at some length, I think, the other morning. So we take a look at this is a typical PowerShell command. Here it expands into a set of tokens, or parses into a parse tree, basically. And the distinction being, actually I screwed up that example. My apologies. It should say $command, not var. Yeah, sorry. Yeah, and I just screwed it up. I just don't know what I'm doing. So it compiles into a parse tree node that says this is a variable whose name is command. So it still contains these unevaluated variables, and then you can compile it. So this means that PowerShell scripts are compiled once when you read them, and only once. And every time through it does this evaluation and retrieves variables and so on. So this has an obvious problem is that you can't just say $command at the beginning and expect it to invoke your command. We had to have the call operator. And the downside is it also restricts aliases to only contain command names. So in a Unix shell, you can have an alias that says ls-l. And that will get expanded into a string that says ls-l and then parsed into command ls and argument l-l. You can't do that in PowerShell. So our aliases are limited. We've made several attempts at figuring out ways to do that, but none of them have been particularly successful. Bimodal parsing shells tend to have extremely complicated parsing rules. I recommend the PsObject.2 shell grammar to your attention. PowerShell has essentially 2 modes. So this reduces the number of modes in parsing to a much more tractable number, command mode and expression mode. The overall parsing mode is determined by the first token in the line. If it's a bare word, then it's a command. Otherwise, it's an expression. In command mode, arguments are parsed as either parameters, which are bare words, like things not in quotes, or expressions that start with one of a small set of characters. And so you can say something like get -foo -bar $foo. So $, says that this is actually an expression, and so it allows in the grammar it's a simple expression is the production. It's limited to things like variables and then properties and method accesses. We wanted to have a simple core object model. So .NET has thousands and thousands and thousands of types that you have to deal with. We didn't want the user, the relatively novice user, to have to deal with that many types. And so we decided that we would provide a much more basic model with 5 basic types. So strings, numbers, which was tricky because there's no universal number type in .NET. There's just many numeric types. Arrays, and again, we wanted arrays to be the simplest type, so not a generic, that's confusing, not an array list because array lists are stupid. We just wanted to have basic arrays. Hash tables, obviously. And then objects with properties. So from the user's perspective, it's a PsObject. And so you'll see suggestions where people say, well, why don't we replace arrays with list of something or other? Or why don't we honor strongly typed collections in concatenation? And thinking at the time was, no, it's better to keep, not only to keep, but to move everything into this sort of canonical small set of types. We may not be right on that, but that was what we were thinking. This is mostly visible in things like how the operators work. So if you take an array list and add another number to it, you'll end up with an array with that additional number. You won't end up with an array list with an added element. And then types are very first class in PowerShell. So casting, using them for dispatches, assigning them to variables. We make it a great deal easier to use types as first-class objects than most languages. Booleans, this one came based on feedback from the last talk. Everything in PowerShell has a Boolean value, 0, null, false, and the empty string are all false. Non-zero numbers, non-null pointers, non-empty strings, $true are all true. A relatively small set of things that's fairly easy to understand. It has the downside that false is true. We do some special handling for Boolean parameters. If you try and pass a string as a Boolean parameter, you'll get an error. You can only pass true, false, 0, and 1 to Boolean parameters on the command line. So they wanted to have true and false be Boolean true and false. I didn't want it. And so we came up with this compromise. My concern was I had worked a lot with the Tickle language, and it had true and false and T and F and yes and no, and there were so many strings that were true and false that I just thought it was fragile, and I wanted to be more restricted in it. Language evolves, splatting. A common scenario in shell type scripting is commands calling commands. So you have a wrapper command that calls another command. This is easy in expand and parse because you just put the variable on the command line and it expands into a string and then it gets parsed. It doesn't work in a fully parsed language where you put the variable on the command line and it gets parsed into. This is a variable reference, not the contents of the variable. And so we added splatting, which I took from Ruby. There are other languages that have it, but I took it from Ruby, okay? We didn't want to use splatting because the splat character is the wildcard character on the command line. And of course you wanted to be able to say, splat a variable on the command line. So we used @ because it's the character that we use for arrays pretty much everywhere else. And for those who wonder, well, I'm not sure which came first, but splatting is the asterisk looks like something has gone splat on the wall, so that's why it's splatting. The @ symbol is less so. Note there's an RFC for making splatting more general. There's a bunch of scenarios where we could expand splatting. It's fairly restricted right now. It's in GitHub RFC repository. Please read and comment if you are so inclined. Scriptblocks and call. How much time do I have left? Oh, okie dokie. So we needed the call operator to do indirect invocations. You saw that with script parsing. The Scriptblocks came about in a funny way. Somebody from the MMC team wanted to be able to have regions of code in a script so that they could have different actions associated with those regions of code. To me, that sounded like a job for Lambda functions. We didn't want them to terrify people because people are afraid of Greek letters, and so we called them Scriptblocks. So people use lambdas all the time with where and for each commandlets, and don't know there's anything fancy about them at all. Script blocks are actually the core of everything, though. A script is just a script block on disk. It lets you do things like WinForms programming with delegates, methods are script blocks. Everything is a script block. And so it's an important class to go through and understand. The class has grown considerably since I first wrote it. It has an awful lot of invocation methods on it now. And because script blocks are functions, so functions can take parameters, so script blocks can take parameters, and so you can define a function simply by assigning a parameterized script block to the function drive, which is sort of cool. Actually, the dirty secret is you can actually assign a string to the function drive, and it will automatically compile into a script block, which I hate because it's another way of accidentally getting code injection vulnerabilities. But it's there. The developer who did it hasn't been with the team for a long, long time. I didn't know he'd done it, so I was upset. It's an expression-oriented language, so everything returns a value. You don't have to say return, everything just returns a value. The downside is that everything returns a value. Every statement in a script returns a value, and this can be problematic. We changed the semantics for methods. So we have dynamic or lexical scoping. Well, lexical scoping is what most programming languages use and is well understood by the programming language communities as the right answer. So we didn't do that. We have dynamic scoping because that's what shells do. We have a modified dynamic scoping because it emulates what the Unix shell does. That actually lets you, it eliminates a large chunk of the problems that you get with traditional dynamic scoping like an eLisp, but it still has its issues. It also has its benefits. It makes it, you don't have to have 1,000 parameters in a function. You can just pass them through the scope. Should be dash or slash, dash, duh. Switches were a little bit weird. Originally, they were just going to be Booleans. Then people wanted to be able to pass Boolean values. I wanted to have my Boolean parameter $true or my Boolean parameter $false, as opposed to a switch is simply present or absent. So we invented a switch parameter type that's essentially like a Boolean. It's convertible to a Boolean, but tells the parser that it doesn't. This parameter doesn't take any arguments, except when it does. So if you use the colon notation, you can actually pass an argument to an argumentless parameter. And that's also useful for commands calling command. Shells deal with strings, so everything's a string. PowerShell lives in a world of objects, but it had to behave like other shells. How do we make this happen? Well, we did this through super aggressive type conversion. So we will randomly, if you pass a number to something that needs a string, we'll make the number into a string. If you pass a string to something that needs a number, we'll make the string into a number if we can, otherwise we'll generate an error. So there's as opposed to Python, which says favor explicit over implicit, we're like, oh yeah, totally implicit, dude. But it also means that it does a bunch of guesses. It has a set of algorithms that try and figure out what the best, the optimal conversion is. But it essentially means that it's doing a bunch of searches, and searches are not super fast. So you're searching for the best type. We had a type distance algorithm. Dongbo tells me that it got removed. This was an algorithm for saying, well, I want an int, and I have a double, and I have a decimal, and the double is only 3 away from an int, and a decimal is 5 away from an int, so we'll favor the one that's the lower distance. And that was used for argument binding. The parameter binder didn't do that. It used a different approach. It did a different approach that was a hack at the time that is now preserved forever in PowerShell, and that is it did a 2-pass binding. It did a pass where if the argument type and the parameter type were an exact match, then the bind would succeed. And it actually ran all of the bindings concurrently. So it's binding every variable in the parameter set. If you have a parameter set with a lot of variables, this can be like really expensive. And so if it didn't find an exact match on the first pass, then it starts all over again from the beginning, but by doing conversion. So, and it doesn't do the best conversion, it does the first conversion. So, shipping. Shipping's a good thing. As Jeffrey says, to ship is to choose, and so we're getting around to the time frame where we're actually being allowed to ship, and we have to start making choices about what we will and will not ship. And this was a quote from Jeffrey from the American Summit. He described trying to ship PowerShell was like being a cockroach in a room full of cowboy boots. Everybody is trying to kill you. Microsoft at the time was co-opetition, I guess was the word. Anyway, everybody was very aggressively fighting for resources, and Jeffrey says that he describes his life as being a pariah for a couple of years. But I certainly remember, I have a few wounds left over from cowboy boots. So shipping is fun. We should do that. PowerShell started as an independent project inside Microsoft. We had our own build system, and we were going to ship on its own, so a separate package, not part of Windows. PowerShell joins Windows, oh whoopsie, they have their own build system. We will now shift our build system to their build system, and we will ship with Windows. Longhorn. Oh my God, Longhorn explodes. We were .NET. .NET was evil. All of a sudden, that went from being the darling to suddenly evil, and so we were kicked out of Windows, which was interesting. Crap, now what do we do? Okay, we're drifting aimlessly, and along comes the Exchange team riding their white horse. They had actually been investigating an automation solution for managing the Exchange server that was very much like what we were doing with PowerShell. And in particular, the object nature of PowerShell meant that it's much easier to build a graphical user experience on top of a PowerShell command. And so we all got together, and so we had a new partner and a new shipping vehicle, and everything was golden. It had some impact on the product. Obviously, Exchange was focused on Exchange's features first, and one of the most obvious ones is that the native command support was weak in PowerShell v1, and it's still weak. It's never gotten the attention that it really should have had right at the beginning, because it is a shell. So finally, we get approval to ship as a Windows feature, not as an Exchange feature. Yay! This is post Longhorn at this point. But first, we have to pass some gates. So we have this versioning requirement. Windows says, thou shalt never, ever break anything. And sort of, they're going from a situation where they had loose versioning with DLL hell to this incredibly rigid and brittle versioning system where worse is better. It's better to be completely useless than to be possibly wrong. I don't know that I would agree with that. And as Jeffrey says, versioning is not a problem because problems can be solved. Versioning can't be solved, it can only be mitigated. It contorted the design of the runtime in some significant ways, like the introduction of the I command runtime, which is one extra layer of indirection between a command and the command processor. So it's overhead. It turns out to have the occasional use, but it's really just overhead that we had to introduce to make everybody happy, to make the people who could kill us happy. The no plugins requirement, well, that's sort of a problem for PowerShell because PowerShell is all about plugins. Our first attempt at solving, I was hanging like every 3 seconds, and they were all upset. So we needed to come up with a solution for mitigating problems with plugins. Our first attempt was a mini shell. So rather than having a plugin model, what you would do is if you were the Active Directory team, you would produce the Active Directory mini shell. And if you were the SQL team, you'd produce the SQL team mini shell. And if you're the networking group, you'd have the network team mini shell. And each of these shells would be calling each other. So you could have potentially dozens and dozens of PowerShells on your box, all talking to each other out of process. And there's residual, there's the fact that if you say PowerShell, squiggly bracket, some code, close squiggly bracket, in PowerShell today, it will create a shell and pass the code to it through base64 encoding. That's left over from the mini shell. It is frequently useful, but that's why that's there. There was a now somewhat opaque reason for it. Round 2 was snap-ins, because MMC shipped with snap-ins, so clearly we should be able to ship with snap-ins, and we got grudging approval. It turned out that some of the Windows core architecture team had a huge hate-on for snap-ins. So your mileage may vary, but it did actually kind of let them approve us to ship. And you can see the leftover stuff. So mini shells begat single shell, and that's why you'll see dregs of stuff in our code called single shell. It's because this is what was done after the mini shells. And it's just like incomprehensible without knowing the history. The next step was language reviews with the CLR and DLR teams. DLR had just started. Link was a new feature in C#. PowerShell kind of looked like Link. We should talk. We did. We used a push model. So Link is a series of enumerators that pull. PowerShell is a series of commands that push. Some people felt that was bad. But we had a very nice chat with Anders Hellsberg, and he said, oh yeah, I understand what you're doing, you're cool. So it was good. We were able to go. And it turns out after many years later, the RX, the reactive framework shipped, which is all about push. So we were totally not wrong. So it resolved without much difficulty. Then there was a fire drill around somebody discovering that you could build PowerShell with, or build software with PowerShell. Oh my God. MS Build was new. It was a big effort from DevDiv. They were afraid that we would confuse the customers because DevDiv is not Windows, right? So a different customer base. Two mechanisms unknown. Somebody saw a slide that said, oh yeah, we can build PowerShell. We can build software with PowerShell. This was bad. It was an unfortunate misunderstanding. But we looked at the technology stack. MS Build is more or less correspondent with Ant. PowerShell is correspondent with Bash. Make is correspondent with, well, Make. And once that got clarified, then it wasn't too bad. So we're all clear to ship, except one last thing. Couple minutes. All clear to ship. We had to change the product name. So that was, we did a survey to justify changing the product name. Well, the marketing guy that we had is the only time we've ever had a marketing guy. Usually we're so far from marketing, we don't even know what building they're in. And the survey said basically, which name sounds more powerful, Monad or PowerShell? And which name sounds more like a shell, Monad or PowerShell? You can guess what happened. So we had this required lots of code changes, setup changes. We had to change all the reg keys. We changed almost everything except there's still some traces in the code, like the PsObject is actually called MSH object. Oh yeah, and you guys are lucky because at one point they told us that the executable would have to be Windows powershell.exe. So we convinced them that PowerShell was, it's enough. Nobody will mistake it for a ski boot. It's okay. So PowerShell finally shipped in November of 2006. Yay! Slide says I need a summary. Sure, stuff happened. We shipped. There was cheering. Yay! Please join me for the second half of this talk. We'll cover the rest of the history of PowerShell. Okay, round two of two-round set of talks. There you go. Skip. Stuff about me. Remember, if you have questions, anything about suggestions for things that I didn't cover or haven't covered, things I missed, things I got wrong, please let me know on Twitter or hit up the PowerShell team Twitter alias. Okay, we shipped V1. That is awesome. Maybe if we're really good, they'll let us do it again. So V2 is an in-place update to version 1. It had to be in-place update. All the assemblies are in the GAC. So the CLR team had created this rigid versioning model where all of the types are strong name signed against an assembly. Basically, it meant that you didn't have a servicing model. You couldn't change the types unless you lied, and that's essentially what we did. And that's why you'll see that even though we're PowerShell version 6, we're still in the 1.0 directory, and all of the assemblies still have the same version number, because if you change the version number of the assembly, you change the type of all of the types in the assembly. So it was a big release with a lot of new features. Version 2 was very big. To a large extent, it was because we had so much built up from version 1 that building all the stuff we wanted in version 2 was pretty straightforward. There were, I believe this is true, to the best of my knowledge this is true, there were no intentional breaking changes between V1 and V2. There was no such thing as any change is potentially breaking, but we defined, we have a well-defined notion of what is a breaking change. So PowerShell version 1 supported multiple run spaces. It supported this through a class called run space configuration. Run space configuration was invented for I talked about single shell before. It was invented for single shell. It was a way of saying what things should be loaded when you started the shell. It had this interesting characteristic in that it was a live object. So you could create 3 run spaces from one run space configuration, change the run space configuration, and all 3 run spaces would be updated. This is sort of cool in one way, ignoring all the threading issues, but it really isn't what you want to do. And the other thing is it was very limited in the types of things that you could pre-configure. You could only pre-configure commandlets. So we created this thing called initial session state, which is a class in the code. And it was designed to initialize, so rather than run space configuration, which represented the run space configuration as it was running, this was initializing the session state. And it had support for all of the command types, but also had support for variables. So you could have initialized variables stored in your initial session state. One thing that was really, really important, so every type of command had a session state entry type associated with it. All of these types had a visibility property. The visibility property was used to determine whether that command was visible outside the run space. So if I sent a command request in from the run space and the command visibility was run space only, was internal, then you wouldn't be able to execute it. So basically it was hidden from the things coming across the run space boundary. Every command that came across the run space boundary got tagged. So commands that were executed internally were tagged as being internal, and commands being executed externally were being tagged run space. So you have this sort of security model around the visibility of commands. This was the basis, if anybody's used Exchange, hosted Exchange, this was the basis of their RBAC model. Based on your account, they would generate an initial session state object that would give you the set of commandlets and parameters that you were allowed to use. You may also recognize this concept as the underpinnings of GIA, would eventually turn into GIA. The PowerShell API. So version 1, we did have a C# API for invoking PowerShell stuff. It was a little clunky. It was a little hard to use. We decided that we wanted to do a much better job in PowerShell v2. And so we created the PowerShell API. This is what's called a fluent API. That is, using the API is supposed to be read semantically rather than imperatively. It follows a builded pattern. So for example, we have a command that looks like this. Dir, sort, select. The equivalent command using the PowerShell API looked like this. So you create a command, or you create a PowerShell object, add a command dir, add a command sort, add an argument length, and so on. This is a little bit, it's not quite where I wanted it to be. I think it should have said .command, that it should be declarative rather than imperative, but it's a lot easier to use than the old API. And this was actually, interestingly, I got this idea from Jim Huguenin, of IronPython and DLR fame, because he was trying to figure out PowerShell from the Python perspective, and he had basically built up a set of classes in Python, IronPython, that let him run PowerShell that looked fairly native to Python. So that was very cool. It seemed like a pretty good idea. Modules. So we had CPAN Envy big time. We wanted to have a module archive, but first we needed to have modules, right? There's always a first step. This feature was not originally planned for version 2. Version 2 was a full release, and about a year before we completed the release, we decided, modules, that'd be cool. Let's do that. And so we started development of it very late in the game. Most of the work that I had done with initial session state had set up the underpinnings for what I needed for modules. So I got the basic module stuff working in several weeks, right around Christmas time, as it turned out. And that was cool. So we thought, yeah, we can do this. We can finish this in time. But the devil is in the details. There were a ton of things around dependencies and imports and exports and so forth. Discovering, loading, and unloading is all dynamic, so it's all done at runtime. This is very natural for PowerShell, but a little strange for most languages, where most languages have module loading at compile time. And they do it with syntax rather than commands. Modules are first class, so you can get a module info object like everything else in PowerShell. You can use them to do some interesting things. You can evaluate a script block in the context of a module scope by using the ampersand operator. I had thought that we would do that you would be able to do this, for example, with a run space as well. I think it would have been very slick for doing this with a run space, but that didn't get done. But you can, and this allows you, the primary scenario we were looking at for this was around module debugging, because it lets you get into the module and you can see the variables that are, the private variables in the module become visible when you use this technique. The heart of the module is a session state object. This is the same type of object. So every run space has one session state object. That session state object holds all the global stuff. To make modules work, I said, I'll just reuse session state. I'll create a new session state object that is specific to the module, and then I'll link them together. So a session state object can have has a parent object, and it looks in the session state object. If it isn't there, then it looks in the parent object. They're only linked one level, so and they look in the global state of the session state. They don't look at the dynamic state. This was quite easy to do, but it's also very, very heavyweight, because session state has the commandlet table. It has a ton of things, and so it's not cheap. Obviously, we have the different types of modules. Script modules are obvious. Binary modules are obvious. A manifest module type is a little strange. Manifest module type is a manifest only. You can have a module that doesn't import anything, just a PSD1 file. You can have a module that just has nested modules that are other modules, and it can take the APIs of one module and republish them as APIs, republish the APIs to its own manifest as a different set of APIs or a subset of APIs. So you could kind of use module manifests as lenses. We had thought that this would be used for more things. Again, it's somewhat conceptually similar to GIA, right? It's a declaration of a set of commands that are visible through a boundary, but that never got developed beyond what we did in V1. Modules are loaded only once. If you load it again, it'll check in the global module table, and the global module table stores modules indexed by file name, like the absolute path. And so if you have it loaded once, even if that file has changed, it won't load it again unless you explicitly force it to be loaded. Because modules can be used by other modules, when you do a forced module reload, we don't do a recursive force of all of the modules that it uses. That seemed sensible. It's kind of a problem for module developers. Maybe we'll come up with some alternative way of doing this. Removing a module was a nightmare because stuff is everywhere. As long as you have any links, like you have a function in a scope that you're not currently using, as long as that function still exists, the module remains loaded, et cetera, et cetera. So there's a lot of cleanup involved in removing a module. We almost didn't ship it. I had some long discussions with Don Jones about just how much he hated the way removing modules worked. And of course, again, if you remove a module, it doesn't remove the dependent modules because the dependent modules might be used by somebody else. A lot of this has to do with, well, part of it has to do with coherence. A bunch of it has to do with performance because loading is fairly slow. There are a couple of advanced module features that most people don't know about or use. So dynamic closures. A dynamic closure is a script block that wraps a module. So a module wraps scripts, but a closure is a script that wraps a module. So they're kind of duals. And so you can do something like this. This is a function. This is not a counter function. This is a function that defines counter functions. So it defines a variable $count locally and then returns a closure. So using it, you get something like this. So I can define a function, myCounter, by simply calling the counter command. Now, every time I call counter, it'll incrementally count up one variable, because the local variable in the counter function was captured by the closure and now becomes a module scoped variable in the counter in the bound function, the new function, the counter function. And then modules as custom objects. Somebody was doing something with this earlier this week, but I don't remember what. But this is the ability to define a module as an object. So you get an object back, and all the public properties, or all of the public variables in the module become PS variable members on the object that gets generated. All of the functions become methods. And so this was kind of a slick little way to generate objects that nobody uses, and is, again, because each object wraps a session state object, it's pretty heavyweight. We'll talk about it a little bit more later. Remoting, so we didn't ship remoting in version 1. That's like something we needed. So we actually got to the point where we almost did a version 1.5 just to get remoting out for exchange. And then things got rescheduled. The basic design of remoting had actually been done in version 1. And some of the bits were serialized in the form of export CLI XML. So the basic serializer, the CLI XML serializer, had been done in version 1. And that's part, or a big part of the serialization protocol that's used in remoting. It's a lossy serialization, a small number of types that we guarantee are everywhere, and everything else is property bags. We actually broke that in version 6 because we added a new type, PS semantic version, that isn't in the old ones. And so we serialized PS semantic version with fidelity, and it barfs when you try and deserialize it. I'm not sure what we've done to fix that yet. Version 1, anybody know the WCF, Windows Communication Foundation? That was part of the family of foundations that .NET was doing. It was a way of doing networking based on .NET. It was the thing to use at the time, but in practice we didn't do that. We used Web Services for Management, which was just out. If Steve is around, Steve Lee was one of the developers on the WSMan stuff. If you have deep questions on WSMan or WinRM, he's your guy. We used the non-standard shell protocol. There was a ton of performance work, but this is still fundamentally an XML-based protocol, and so that makes it slow. We had done work on a binary protocol, but that never got completed. And also, the protocols under the Microsoft Open Promise program, these protocols are both completely documented, and anybody can implement them. I'd really been hoping somebody that would do that, but that never happened. So the designation is MSPSRP. You can look the protocol up online. It's fully documented, and WSMV, which is our extended version. WSMan itself is a DMTF standard, but WSMV is our extensions to WSMan. One of the big new features in version 2 was the ISE. We used a split pane shell experience where your input was in one pane and your output was in another. It seemed like a good idea, but it didn't go over very well with people. Tab completion was there, but tab completion was based on the version 3 we introduced a new parser and new tokenizer. In version 1 and 2 we used the old tokenizer. You can weirdly find this class in SMA engine parser. There's actually a bunch of classes. There's a parser class, a language class, and a runtime class. And the parser is actually in the runtime class. No, the parser is in the language class, language subdirectory, not in the parser class, parser subdirectory. Just to be confusing. One of the things that we did one of the things that ISE drove was a change into how we handle threading. In version 1, or in part 1 of the talk, I said that we thought about everything. There are some things that we thought about it and then didn't do anything. By default, executables created with .NET in version in CLR v1 and 2 ran with multi-threaded department. And we said, oh, we should think about that. We'll just ship it MTA. So it was one of those unintentional decisions. In fact, it turned out to be not a great decision for certain types of things. It made using COM hard. It made using WinForms and XAML in particular difficult. So we gave you a choice. Rather than deciding to do the new right thing, we dithered and said, well, you can choose and use either -MTA or -STA, depending on what you want. Default, I think we finally decided the default for V2 would change and it would be STA, making it easier for people to build GUIs. Pardon? Part of it is because ISE is XAML, so if we wanted to be able to manipulate it with PowerShell, we needed to be in the right thread model. We had COM in V1, despite being MTA, what we ended up doing is creating a separate STA thread for the COM objects and then marshalling across the boundary. So it was like weird and flaky. And the other thing is just, so again, one of these decisions that we thought about but didn't do anything about. So when you use the PowerShell API default, when you say invoke, it creates a new thread to execute. So invoke is a synchronous method call, and despite being synchronous, it creates a new thread to execute the PowerShell command. That was entirely an artifact of Jeffrey's prototype didn't have Control-C. So I said, what can I do quickly? I'll add a separate listener thread, and there'll be a worker thread, and then you hit Control-C, I'll just kill that thread, which is very bad practice, but it was super easy. So all of a sudden it had Control-C. And that just kind of propagated into the PowerShell runtime. So we were always creating this thread that we didn't actually need. And you also have, in the API now, you have a choice to say run on caller's thread. So some of the stuff is like weirdly justified, I suppose. There's a whole bunch of other stuff that we did. We added new operators, split and join. This kind of completed the set of string and array operators. We didn't have any way of really, you could do regex, but you couldn't do a split and a join. So this kind of completed the set of things that we thought that the mid-level user, so there's the user that's just using commandlets on the command line, and there's a guy who's a little more sophisticated, they're using commandlets and some of the operators, and there were things that they couldn't do with operators that you needed to do, so we added the extra operators. And then there's a level up, is somebody who's perfectly happy using methods, and then methods you could do everything. We added the data language, which is a constrained language in regions in the script. This is a way of introducing stuff that is only data in a script in a secure way, and it's used for internationalization primarily. It's also used for module manifest with the PSD1 file, which means that these things are safe. Right? There's no code. There are no or minimal risks associated around loading a PSD1 file because it can't contain code. Block comments, very popular. I talked us out of doing it in V1. I was wrong. The ability to assign the output of a statement directly, so something like this. In V1, you had to use a sub-expression. You could do this, but you had to wrap like a while statement in $parens in order to be able to do the output. I changed the parser in V2 so that you could simply do an assignment. And this is our answer to the ternary operator that you see that everybody wants in PowerShell but doesn't actually need. And it also means you can do things like this. The other point of this is this is the fastest way to aggregate collections. So rather than doing my collection plus equals 1, which involves a whole bunch of copying, if you do this, PowerShell will buffer up all the objects and then turn it into an array at the end. So this is really the fastest way to build up a collection of objects in PowerShell. And it gets, I just don't think we communicate it very well. PowerShell version 3. This is a big deal because now we're moving to a new version of the CLR that is it's backwards compatible but not forwards compatible, something like that. And so this was a big change to everything that we were doing. It also meant that we went side by side because the CLR2 and CLR4 were side by side. PowerShell 2 and PowerShell 3 went side by side. We deliberately took some small-ish breaking changes. I feel dirty reading this statement. We took advantage of the fact that we were going to a new CLR to justify fixing things. So it's probably a good thing. One of the problems that we did have, though, is it took years to get significant uptake of PowerShell v3, despite substantial advantages to using PowerShell v3. A big chunk of it had to do with the new CLR. People really hate to change their software, except for Tired Joey. We had a bunch of themes in PowerShell v3. Multi-machine management was one of the big themes. Coverage was one of the big themes. So multi-machine management, which essentially turned into workflow. The code name for workflow was M3P for multi-machine management project. I wanted that code name because I thought it was so horrible it would not. Cool code names live on forever. Lousy ones just die. I wanted the worst code name I could come up with. Based on Windows Workflow Foundation, which is WF, it's not WWF because it's wrestling. Wrestling is WWE, it's the World Wildlife Foundation. So couldn't call it WWF, it's WF. WF is a language, it's pretty much what it is. It's a language with very strict semantics, with lexical scoping, a lot of the traditional programming language stuff. This meant that PowerShell had to include an entirely distinct execution engine inside its process. We mitigated the burden of doing that by having a syntactic fiddle so that we didn't load the engine until the first time you actually tried to execute a workflow. One of the big decisions that we made is that we decided that workflows should look just like PowerShell. So scripts converted to XAML. XAML is what workflow ran. Scripts would convert to XAML. XAML references activities. So every command got a corresponding activity. You can see this in the source code with blah, 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 dot activities in the source. We introduced a new module type for pure XAML workflows. Workflows look like functions except for the workflow keyword. And it was probably a mistake, looking back. A lot of the value of workflow comes from presenting a restricted execution environment. DSE is similar in concept. What we had done is we had worked really, really hard to produce an execution environment that had as few restrictions as possible. And there was just this impedance mismatch between the way workflow was to be used and the way people could use it in PowerShell. So people would treat it like a function as though it were a lightweight thing, even though it had this huge overhead. It wasn't without advantages, because it allowed for highly parallel execution. So we have a workflow. I introduced a parallel statement, so this starts several parallel threads of execution, 1, 2, and then a third thread. The third thread of execution is actually, for each in parallel, is going to create 5 new threads of execution. So we have a total of 7 threads of it, well, might be 8 threads of execution, all within one fairly small script. Looks easy, looks lightweight, but there's a bag of stuff going on. Every execution is a run space, so it's very heavy. And then we had another level of concurrency. I can start this same workflow. I can start it on 3 different computers simply by saying PS computer name host 1, host 2, host 3. So now we have 8 threads of concurrency across 3 machines. That's a lot of concurrency, and it's expressed very, very simply. But there's significant overhead in run-space concurrency. So this makes sense if you're doing a bunch of long-running operations. It makes 0 sense if you're trying to do something very quick and dirty. And we just didn't make that distinction clear in what we were doing. So it just didn't turn out the way I really would have liked. Life's disappointments. Sim commandlets and CDXML was another huge effort. We had all the WMI stuff from V1, V2. The sim commandlets were new for V3. A new sim provider model that was supposed to be much easier to write. The ability to take a sim provider and synthesize a commandlet directly from that sim provider, from an XML representation. And that was a huge advantage, gave us a huge advantage for coverage, because most teams would they had to do the graphic management stuff, and then they had to do the command line stuff. Well, now they could just write their SimV2 provider and some XML, and they got a commandlet for free. And we made sure that the provider model supported like the alternate streams in PowerShell. So there was a lot of synergy between SimV2 and PowerShell to allow you to get good results. New module type. And this is where the synergy came in really very handy, is there was a huge increase in coverage between PowerShell v2 and PowerShell v3, just because all these teams had built these new SimV2 providers. Also new, so we had the old WMI commandlets. We got the new SimV2 commandlets. Get sim instance instead of get WMI object. They're pretty much compatible with some enhancements. One of the things is sim sessions. So if you're connecting to a machine and performing a set of operations, get WMI object would create a session every time. You could create a session once with new sim session and reuse it in the sim commandlets. So a great deal more performant. The new sim protocol was a great deal more performant. Let's see what else. Oh yeah, sim instances don't have methods. So you could get if you did get process win32 underbar, get WMI object win32 underbar process, there'd be a kill method on the object you got back that you would kill. The thing is that object would then have to do a remoting call to the sim server on the target machine to actually get it to do the kill operation. So every time you got these objects back, you got these sort of live proxy objects that had to distribute type information and maintain their connection and flakiness and all these things that you get from these distributed objects. The sim model didn't do that. It only had properties. You could invoke instances with the invoke sim instance or invoke sim method commandlet, but you couldn't just there were no methods on the sim class that you could just invoke. This was a big change, but it just allowed for a much more performant system. New parser and the DLR. The first version of the language was written by me to be very, very general. So it was a recursive descent parser. It was not optimized. It had some parsing issues, and the tokenizer was a little funny in a way that the tokenizer was very general, and that made it quite slow. So version 2 introduced a new parser and tokenizer in the lang directory. It's much faster. It's still a recursive descent parser. The developer who was working on it struggled for a significant period of time trying to come up with an antler parser, a generated parser, but there were enough nuances in PowerShell that he couldn't really get that to work. The parser produces a public AST. So the V1 parser produced a private expression tree. V2 produces a public AST. This is super important because it allows you to do tooling. It allows you to do analysis of your scripts in a deep way. The other thing is that it contained, where V1 parser contained the index at the beginning of the token for an error, the V2 parser contains an extent, so it has both the beginning and the end, so that you can tell where, you can show the squiggly under the whole token. So it just allows for better error messages. We use DLR expression trees for the runtime. We use calls like caching for dynamic dispatch, which means that it's a much faster language. We have a blended interpreter compiler that Donbo discussed at length. Because compiling is expensive, we try and detect when is the right time to do a compilation. It just means that you don't have to worry about it. We try and deliver the best performance. Think of it like garbage collection. The runtime is in SMA engine runtime. The net result was that the language performance improved 8 to 10 times. So that was like huge. With the downside that the pipeline performance hadn't changed from V1, and it kind of sucked. And one of the reasons is this. So this is something that Staffan Gustafsson nicely provided to me. This is you can probably barely see that. Yeah, you can barely see that. Just see that there's lots and lots of lines. This is the dependency graph for the parameter binder. This is all the stuff that goes on when you bind properties or parameters in PowerShell. Yeah, it's slow because it's really, really complicated. I'm aggravating to get this fixed. I'm sure there's some low-hanging fruit that we can do to optimize simple cases, and then we can do some work to make it generally faster. But the trick is that it's a very large piece of code. It's very, very complicated, and its behavior is very subtle because it's search-based. It's hard to predict. You can predict the behavior, but you have to know the circumstances, and so changing the parameter binder significantly could accidentally change the semantics of the parameter binding, and that would be bad. You could break scripts. Remoting changes, we have connect disconnect now. Reliable connection, so transient network problem won't cause your connection to drop. This was all going to be endpoint configuration files, so new session state configuration file. This is a declarative way of creating an endpoint configuration. Again, rather than generating a new session state object and imperatively filling it in, you could declare it. I want to go back to that one thing. So a lot of this connect, disconnect, and reliable connections is all centered around this idea of multi-machine management. If you have long-running operations, you don't want to have to sit in front of your desk for a long time to wait for that to complete. You wanted to be able to, shut down your laptop, go home, have a beer, come back, reconnect, find out the status of your job. So workflow is very job-centric. But there's one piece that we didn't ship in V3, and that was this idea of a mid-tier server. So we were going to have a work service where you could start your jobs, disconnect, and then reconnect to that service, and that service would handle orchestration of the jobs. We had great plans. We ran out of resources and time, the usual. Speaking of time, how am I doing? I've probably got no time left. Oh, awesome. So good. ISE, single pane scripting experience. Yay! This made everybody happier. It became much more of a shell experience. The ISE is based on a control that we got from the Visual Studio team. It's the same control that they did use in Visual Studio. I don't know if they still use it. In version 3, we got a new version of the control that had a bunch of features like outlining and line numbers and things like that, exposed in ways that we could take advantage of it. This is also, by the way, you'll never see the ISE open sourced that I'm aware of, is because it's based around this control that is based on source that is closed source for Microsoft, and it's closed source because the people who own it don't want to maintain it and support third parties in the open source. So we're kind of stuck with this boat anchor. So VS Code. One of the big changes, Jason, the developer on the AST, worked a lot with the ISE dev to do IntelliSense-based AST-based IntelliSense. So IntelliSense became vastly smarter in version 3 of the ISE. And then we also got real IntelliSense with drop-down lists and so on. Other stuff, added snippets, we added a help window, we added the show commandlet, both snapped into the ISE and as a standalone commandlet. Show command is almost great. It could have been great, but it's not quite great. XML syntax highlighting, we added highlighting for second language. I can't swear there was actually a scripting model in version 1 of the ISE. Maybe there was, maybe there wasn't. But we got a much improved one in version 2, including things like tool windows and ISE options and the ISE option dialog. So a ton of improvements in the ISE. Other stuff. So workflow always returned arrays. Workflow had the opposite problem of the pipeline. Pipelines ambiguously, a single object returned from the pipeline was ambiguous as to whether it was an array or a scalar. Coming from a workflow, it always returned arrays. Even if the workflow was returning a scalar, it always ended up in an array. So now you're in a situation where you can't tell whether it was supposed to be a scalar or not. And sort of deal with this and make it easier for people to take the output of a workflow and just do property accessors on it, we did property member enumeration. So if you have a collection and the property you're looking for is not a member of that collection, then we will look inside the collection and see if the members have that property and apply that property accessor to every member in the collection. So if you run this command get process, it will return the hour of the start time of all of the processes without explicit iteration. We've added new redirection operators. We could only redirect standard output and standard error. In V3, you could redirect everything. Using variable, so it just made it easier rather than having to have an explicit param statement. When doing remoting, you could just say $using something or other, and it would copy. What that would do is the compiler would detect that you have a using. It would get the local variable, marshal that local variable to the remote target, and make it a variable in the remote run space. Looks simple, sounds simple, not particularly simple. So this is a cautionary tale. We added. People said $underbar is confusing and hard. It would be much easier to teach PowerShell if we didn't have $using or $underbar. Maybe we should have $PsItem instead. So we added $PsItem. And now we have two things that are the same, and it's even more confusing. So this is a situation where, if we had a different idea at the beginning, if we used PsItem at the beginning or $item at the beginning, then that probably would have been better than $underbar. But it's too late. We have $underbar. Removing it would break everything, and adding a new one just adds to the confusion. It doesn't help at all. It's an active net negative. So sometimes when people say, you should change it because this would be better, and we say, it probably would have been better, but adding it now would just be confusing. So you have to think through that lens of experience. Spaces are allowed after dots. We were very restrictive around this in V1 and V2 because of the use of methods in command parameters. We didn't, like if you said foo space $x space $name, that shouldn't be treated as a property accessor on $x. So we didn't allow spaces, but we didn't allow spaces on either side. We relaxed a little bit and decided that spaces after the dot would be okay. And I realized my example is actually wrong. That's so awesome. And we also generalized attributes. So attributes were allowed on, constraint attributes were allowed on variables and parameter blocks, but not elsewhere. And so we just generalized that. You could have constraints everywhere. Ordered hash tables, casting of objects from hash tables into an instance of the object, so you didn't have to do constructors. PS custom object is awesome. The for each statement no longer iterates over null, a small change, but it made people happy. It was a breaking change, but it's really what people expected. Iterating once over null because it was an object was a foolish consistency on my part. Comment-based help improvements, we added --% to make it easier to call native commands especially on Windows. I don't know if it helped. More new operators because we needed more operators. We have more than 50 operators. Why not have 6 or 8 more? Module autoloading. So this made a big difference to the user experience. You could just pick everything up automatically. It's sort of a nightmare if you want to do rigorous or very controlled computing because you're just randomly picking up stuff out of the module cache. So your mileage may vary. Great interactive thing, not so great scripting thing, really. Updatable help was cool. No, it's not a protocol. It's just an HTTP fetch. Trust me, it's just not a protocol. There are a bunch of command discovery hooks that allow you to do pre and post checks on command lookup, or even substitute your own command discovery mechanism. So I talked about the look aside. This is just the look aside. PowerShell v4, in-place update to PowerShell v3. A really short release cycle for Windows. It was less than a year. We had really one big new feature that basically went from nothing to a shipping product in less than a year. It went from an experiment to a shipping product. desired state configuration management. It's an extension. It is an extension to PowerShell. It's not its own thing. It's an extension to PowerShell that allows you to do declarative configuration management, similar in concept to Puppet, Chef, Ansible, etc. The client components are an extension to the PowerShell language. So a DSL for declaratively expressing the desired state of a target. The DSL stuff was actually implemented as a general purpose set of public classes, but it has a downside that it only works at runtime. So if you're not us, you can't hook your own DSL in a nice way. You have to run a script to set up your DSL first and then run the script that uses the DSL. We're trying to fix that. And then the final part of the client were commandlets for managing and executing DSC configurations. There was the local configuration management, the LCM, which was the agent, which runs on the managed node. It ran as a SIM provider under WinRM. And when you got to get your schedule consistency checks, we actually set up a task scheduler task that banged the SIM provider on a regular basis, which is why you had really reduced granularity. You were, the fastest we would run the SIM provider was 15 minutes. So everything had to be like a modulus of 15. It was kind of flaky. And the third component, the providers. You could write them in either C++ or C++ or PowerShell. Turns out that C++ providers are hard to write. We wrote one. It took the whole release cycle to get one provider written. One developer, a whole release cycle to get the file provider written. So we didn't do many more of those. We did a lot of PowerShell providers. I think we're doing more unmanaged providers now. Michael Green could tell you. Pull server. Pull server allows the DSC agent to pull configurations. Not a surprise. So the pull server was supposed to be a sample. It was going to be open source. People could take it and play with it and do whatever they wanted with it. I went on vacation, and it was a sample, and I came back, and it was shipping as a product. So that tells you, never go on vacation. This is really bad. It had very, very limited capabilities because it was essentially a proof of concept. We used REST for pull scenarios. So the client commandlets use SIM to bang the SIM provider to do the configuration management, but the pull server used REST because we wanted to have a relatively simple and easy to implement protocol because then other people could implement it. These protocols are publicly documented again, MSDSCPM, and the protocol is actually based on OData, a very, 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 very restricted subset of OData. It also allows you to pull not just configuration, but also allows you to pull modules. So the local configuration manager will analyze the configuration, discover the missing modules, pull the missing modules, install them, and then do the execution. And finally, the pull server allows status reporting and aggregation of status across a bunch of machines. Some DSC tribulations. So we were doing DSC about the same time that Azure was doing the ARM templates. And there was concern about some confusion between DSC and Azure templates, the Azure team. This led to a really heated discussion, and it led to another great Snover quote. I'm licking your cookie. I'm not licking your cookie. I'm giving you a cookie. We're giving you something that will help you. We're not licking your stuff. I was like the most junior person in that meeting. It was amazing. Where and for each operators, which I personally love, other people can't stand. They're designed for allowing you to do select filtering and manipulation of collections in simple expressions. I mentioned earlier that simple expression is like a parameter argument. So you can do that. Designed to minimize unnecessary punctuation. There's a general syntax change so that if you have a method, you can do a method invocation using braces rather than parentheses, and that will pass a single script block argument to that method. And that's what's used here. It was driven primarily by the need to do PS configuration data processing, filtering from the configuration data, but it's a general purpose product. It is, however, really minimally documented. I was having a discussion with somebody on GitHub, and we really had to dig to find documentation on this. What little there is either third party or side effect. And it allows you to do things like this, dir for each object. So this is a single expression with a minimum number of nested parentheses. And then this is the canonical example, all nodes where $role is web server.node name, right? So we started doing this, we looked at this, doing this with the pipeline, and it just ended up with so many nested parentheses and syntax that we really wanted to have a cleaner, less punctuation-y syntax. Other stuff, new default execution policy on Windows Server was changed to remote signed, a huge win. Save help. Enhanced debugging was a big deal, including the ability to debug workflows. So we ship workflows, but we didn't ship a way to debug them. That was not a recipe for success. So we added the ability to debug workflows, debugging remote sessions. Pipeline variable switch. This was a new ubiquitous switch that you may have wondered why it's there. It's actually there to support Azure Automation Graphical Designer. Azure Automation Graphical Designer is based on, like, we acquired a company called Opalos that had a graphical designer that had semantics where previous entries in the flow graph were available to entries further down. This pipeline variable is just is a way of allowing them to compile their graphical workflows into PowerShell and preserve their semantics. So it's not meant to be used by humans, particularly, but it can be useful. Finally, 5.5.1 in-place update to run PowerShell v4. Surprise. Classes. Classes were probably the biggest new feature. I did a prototype. It took a weekend based on the new module as custom object. Very dynamic. We pretty quickly decided that was a wrong solution. We wanted to have something more rigorous. The goal for classes was Python equivalence. So it's not all of C#. It is the same set of features and semantics that you have in a language like Python, because it's clearly successful. And so it's a trade-off between capability and complexity. And for like something that's successful for a very, very large set of scenarios with minimal complexity was really a kind of a goal. And we're explicitly not reventing C#. And it's not like we didn't think about this. We held weekly design meetings for a year while the development was going on, over a year. Every week we would debate these things. So PowerShell classes are real.NET classes. It means you extend existing types in the framework. All types defined by the class keyword are public. We didn't, again, reducing complexity. Classes and modules are namespaced by the module name. All class members are public, but can be marked hidden, because having private members would actually have made the debugger really difficult. We would have ended up having to do private reflection. Methods have much stricter semantics, so no uninitialized variables, an explicit return is required, and return types are enforced, and there's lexical scope, so you don't look up your caller scope chain to find stuff. This makes it much more reliable to write, or the goal is to make it much more reliable to write PowerShell, to do PowerShell programming with classes rather than functions. Classes are defined at compile time, which is static. Mixing and matching PowerShell dynamic semantics is problematic. We've had several intense discussions this week on exactly where that balance should be, and I don't know where we still haven't come to a proper conclusion. Using module loads a module at compile time, reference types are resolved at compile time. There's other stuff to do. We had planned to do getters and setters. That was in the list. It just didn't get to it. Using assembly with a metadata reader. So we want to be able to resolve types at compile time, but we don't actually want to load the assembly and execute all the initializers and stuff. And so there's a new metadata reader from the CLR team, and one of our devs has an issue to work on this. Loading and unloading types. Other stuff. DSC changes. The DSC agent, so I said it was a SIM provider that got banged by the task scheduler. In version 5, it went to being a proper service. So now you have much better granularity and control over when things are done. We introduced the idea of partial configurations. The core idea around partial configurations is that multiple agents Agencies within an organization might be responsible for different parts of the configuration of a target machine. So the networking team might be responsible for the network configuration. The database team might be responsible for the database part. And so everybody can provide their fragments of configuration which are aggregated on the pull server, or aggregated on the node. This means that individual teams could service their components without having to do a push of the entire configuration. People misunderstood this and try to use it for things that it isn't. Don't do that. The other thing we were able to do is implement DSC resource providers using classes. Again, a more reliable model than functions. To do a DSC resource provider in version 4, you ended up creating a module that had submodules that contained resource providers, that contained functions, that had to have a specific name that we didn't check until it was too late. Classes should make it easier and more robust to create providers. LCM debugging in the LCM, this was another nice feature that got added. Pull server still sucks. Use Azure Automation DSC. That is a full-featured, supported, high-quality pull server. But if you want to go off and write your own, like I said, the protocols are standardized. The protocols are not going to change. If you write a pull server, we won't break you. If we break you, it's unintentional. Complain. We'll grow the protocol, for example, but it'll always be a public protocol. So, and it's really simple, so it shouldn't be that. It's not like Samba. Like Samba's like amazing. PowerShell pull protocol is very, very easy. We finally wanted to get to our CPAM equivalent, and thus we stalked the halls of Microsoft talking to everybody who had something called Gallery. And my God, there were a lot of them. Most of them were inappropriate, focused on their product, very narrow focus, or just otherwise inappropriate. We landed on NuGet. We had a little bit of an issue with the developer folks not wanting to clutter up the purity of their dev gallery with that nasty, icky management stuff, but we kind of got that worked out. OneGet is the universal client module. It was a project from the previous version of Windows that got mothballed. That I don't know if we're entirely responsible for reviving it, but we certainly encouraged for it to be revived. And it's a driver-based mechanism to support arbitrary types of galleries, so that you can have other people's galleries, the same experience downloading modules from different implementations of a gallery. Galleries are not easy. They require a lot of work. They require a lot of work to get set up, and they require a lot of work to keep going. Security, quality, attributes, you have to do a lot of automation. So if you're doing a gallery, expect that it's going to require significant resources. PowerShell v6. PowerShell goes open source. Head explodes. Boom. PowerShell goes cross-platform. Everything else explodes. Boom, boom. Yeah, we broke some stuff. Some of it's deliberate. We have a new CLR. And for the first time, this is not a superset of the previous CLR. It's actually a subset. We have new platforms to support. All of these things introduced, well, in some cases deliberate, in other cases undesirable breaking changes. We worked on this for a year before announcing it, and then we worked on it for another year before going GA, so it was a lot of work. And now, rather than being in place and side by side and in place and side by side, we're now side by side by side by side by side. You can have as many copies or instances or versions of PowerShell 6 on your box that you want. Going open source was a lot of work. So we had to create an entirely new set of processes, version control with Git and GitHub rather than Windows Source Depot, new file layouts, doing continuous integration on multiple platforms with AppVeyor and Travis, building all the community guidance, the RFC, breaking change guidance documents. One thing that's obvious, but not obvious, is if you document something, you really should follow what you wrote down. We've had a few oopsies. We'll be better, we promise. We have maintainers who enforce code quality. We have the committee that steers the language and other functionality. The work we built is a build.psm1 that contains a ton of tooling. We moved the build from Windows Razzle to .NET CMake build. Moving into Test Suite was a enormous barrier to getting things done because the tests were very much tied to the Windows test tooling framework, and so we moved everything to Pester. A bunch of the tests just couldn't be moved. And we still don't have the test coverage for PowerShell 6 that we want. New features, zip, 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 zip. Backgrounding, you can read all this. This is basically the release notes. No breaking changes, no workflow, no ISE because there's no XAML, no workflow, there's no XAML, and there's no workflow. We're making lots of investments in VS Code. VS Code! We have no snap-ins, which is a big yay, finally. It's amazing. There are still, with PowerShell v5, there are still people who are using, at Microsoft, who are using snap-ins, like over 10 years later. Dude. No WMI commandlets, because no WMI, use sim instead. None of the counter commandlets. We removed all scope from most of the aliases because, well, for reasons. None of the direct COM-based remoting still works. So the future, we are now driven by the community more than ever. You can find and fix your favorite bug. You don't just like yelling at us is not your only avenue anymore. You can actively go out and do stuff. But under the current breaking change policy, you can't change how existing features work, and you can't remove things. So the breaking change contract is here, and it has a very, very strong commitment to backwards compatibility. It basically says that you can't do really anything significant to break the language. So you can think of it from the object-oriented thing about, we're open for addition, but we're closed for change. But the urge to fix, which means changing or breaking stuff, is really, really strong. And remember, by design doesn't mean that it was intentional. It doesn't mean it was right. So, if we should talk about breaking changes. Not you guys. So, in summary, we've had a long history over 16 years, six plus releases. There's a strong rationale for pretty much everything we do in PowerShell about how it works. Even so, there might be a better way to do something, but it has to be a lot better if it means taking a breaking change. But please think about PowerShell as a whole. So you might see a micro-optimization. It'd be really cool if I could do this one thing right here, but it may not fit in with the rest of it. Like there may be another way of doing it in PowerShell that might be slightly less optimal, but might be good enough. And adding this edge case would make things worse. Thanks.